Good morning, everyone. We will have a continuation of the topic on acid and alkali. So while we are waiting for all of you coming back, please take out your book. All right, so to take a look on page 15 now of your book, page 15. Now, page 15, this one, okay? To start with, please spend about 1 or 2 minutes to take a quick glimpse of what we are having from page 15 to page 24. Okay, this is our lesson coverage today. So for the meantime, I need to double check your attendance. We've got 27 students here, right? But it seems not all of you are here. Now, please, I'd like to check who is absent now.科比鄭學明張少馮家謙 not here. Okay, that means only Feng Kahim absent. So All right, so we will start the lesson right away. So bases and alkalis. Now, base, that term may be some new term to you. Well, for alkalis, you may heard of this before. Okay, in Form 2IS, while you talk about neutralization, acid plus alkaline to form salt and water, right? So this is what you know in Form 2IS. So acids plus alkalis to remember, okay, to form salts plus water. And we will call that a neutralization reaction. Now, sorry to say that my handwriting today is not so nice because my I feel so cold today. I don't know whether you feel the same, right? A little bit cold. So anyway, so alkalis. So base, what are they? Base, in terms of chemical compounds, so we may get it as a metal oxide or metal hydroxide, underline the term, but not other oxide or hydroxide, right? Metal oxide and hydroxide. So this is a substance when it neutralizes an acid to form an salt and water. So you take a look on this definition, which means that acid plus alkaline or base will still show you this equation. While that general equation, we call that neutralization, right? While you see the word neutralize, right? But is it neutralization? The answer is yes, okay? But what is the difference between base and alkalines, right? You may see the relationship, a big circle and a smaller circle. So alkaline belongs to a very special type of base, okay, which are highly water soluble. So can you see that? Alkalines, they are bases which are soluble in water. So that's why you may have a classification of those chemicals in as a alkaline, just like sodium hydroxide, potassium hydroxide, lime water, okay, and ammonia. All those, they are just water soluble. Okay, they are water soluble. Phùng Gia Hiêm, you are late.
Sorry, I'm going to the E1 classes, physics.
Okay, or maybe you just go to physics then. Okay, bye
Oh
bye.
no.
Now, so for soluble base, water soluble base is like this. So for the other oxide, which we define it as copper 2 oxide, magnesium oxide, lead 2 oxide, iron 3 hydroxide, etc., they are said to be insoluble. So we cannot describe that as alkaline. Okay. So what is the hidden message? How about the one on the right hand side? Can we tell them as a base? The answer is yes. Base, yes. Alkaline, yes. Okay, is that clear? How about this? If you want to tell it as base, yes. Alkaline, no. Okay, because it is not water soluble. Do you understand? So this is what I would like to remind all of you. Now, you may see the following. Sodium hydroxide, we call it as alkaline, is somewhat ionic compound. So once it dissolves in water, the crystal lattice will be broken down. So we would call that ions will become mobile. Okay, will become mobile, and we would say this term a type of dissociation. Okay, all of you please mark it down. Dissociation. 理解 while ammonia gas dissolved in water, some not all of the ammonia molecules react with the water molecules to produce hydroxide ion. So we will call this ionization. We will call this ionization. Why is it ionization? Because you may find the nature of the particles on the reactant side is not ions, right? They are molecules. While for the products, they are ions, okay, for formation of ions for molecules. So we call that ionization. So both sodium hydroxide, calcium hydroxide, potassium hydroxide, the behavior is very similar to the first case. Okay, similarly for KOH, similarly for calcium hydroxide. But for ammonia, the case where we come to this, okay? So what are the in common is that no matter what type of cases do we have, they would have some common ions. So we would have hydroxide ions when dissolving the substance into water. So for those substance releases hydroxide ion when dissolving water, we call that alkaline. Okay, so the properties of that depends on the presence of this. It's easy, right? So if you want to collect some gases, how you produce ammonia solution, it can be done by dissolving ammonia gas into water, right? This is the diagram in which you may find it in DSE past paper as well as third level or DSE past paper. Very often, they would, instead of bubbling directly into water like this, okay, they tend to do this action. Now, tell me the difference between the two, okay? Now the case is this one is not so suitable, right, to be used to dissolve ammonia gas into water. But for this, do you know why? What is the difference? That you may read those readings and try to try to give some explanation to that. Well, do you know? Now you read the wordings first, okay? You read the wordings first.
係咪因為佢 ammonia 唔係好 soluble， 就係佢唔係好溶，所以你用第一個就比較好溶啲咯，第二個就可能有啲就用唔到咯。
ammonia 唔係好溶，有人話 ammonia 唔係好溶。Now, Cyrus, what do you think? Or you just live underwater? Could you please go up to the water surface and say again? I cannot hear you. Sorry, maybe there is a net connection problem. So first of all, ammonia is quite highly soluble in water. Can you see the word very soluble in water? So if I do such action, right, on the right-hand side, what will happen? The gas will much dissolve in the water. So it would have a competition, okay? We'll have a competition of maintaining the water level here. So in one sense, ammonia dissolve water, so they would the water will they will produce a reduced pressure inside them. So they will drive the water level coming up. Okay, can you get the point? So if you want to keep the water level low, or even you want to bubble, what should we do? We try to increase the pressure of ammonia. Okay, it is a matter of competition, of speed, of the flow of the ammonia gas and the rate of dissolution of the gas into water. Can you get a point? So, but however, because of the fact that ammonia being highly soluble in water, so very often we have got a phenomenon of having the water level that rises up. So we would call this type of phenomenon sucking back. Okay, sucking back 倒吸. So the water will be will flow up, right, instead of you see any bubbling. Okay, and they would move it quickly up to here, and they will attack the facility on the left. Okay, if the facility on the left is somewhat very, very hot, of course, there will be crack because I throw some cold water there. Okay, in order to avoid that happen, we have to take a look on these two things, right? First, you tackle the two things. One, we would have the meeting surface here of that large area. And two, you may have the contact surface area on the right-hand side being here, right? A very, very small circle and a large circle here, right? So what is the hidden message? Now, this allows, right? This allows having an inverted funnel like this. It allows a very large surface area of contact. Between the gas and the water. So even though it is hardly soybean water, the water level will not rise too high. So you may see that it occupies a larger volume than next. So it can help prevent sucking back. So what is the hidden message? Suppose we have got the same volume of the nitrogen gas that blow through the water in order to produce aqueous ammonia solution. Can you get the point? And then what's next is to wait until is to check the difference in the water level that rises up. So what is the conclusion? The one on the left-hand side with the inverted funnel will rises with a level little. While for this one, if we want to dissolve the same volume of water, it will occupy the larger space like this. Okay, in terms of larger water level, they will be risen up. So we will call that a sucking back water will occur on the right-hand side. So the procedure on the collection method, the production method on the right-hand side is not so appropriate. Can you get a point? Now, if you understand what I've just said, could you please put a tick? If not, a cross. So in order to make some saying like this, I would like to show you this. And a very authentic experiment. Now, first of all, I have added two chemicals at the bottom. What are the two chemicals?
Sodium hydroxide and ammonia solution.
Yep, ammonium. No, it's not ammonia. It's ammonium. Ammonium chloride plus sodium hydroxide. So once they react with, once I put that two, they will produce ammonia gas. So the equation will be this. You will know it very, very soon. So they try to collect the gas if the round bottom flask inverted like this. So why? Now ammonia gas, it is less dense than air, which means it's lighter, right? So they will go, they will just rises up here and it will dispel. So air inside will occupy the space. Okay, can you get the point? Now, while we are having like this, we are going to put that stopper with a long delivery tube. Can you find that? Okay. So try to see what will happen for that case. I add thymethylene indicator solution. You may search on the web. What is that? Sorry. This chemical. You may may type, you may search this term on the web first of all, and try to see the color change upon different pH, and then try to relate. Give me the reason. Why would it like that later on? Can you get a point? Now I continue. Can you see that? Tell me what happens actually in terms of chemistry. Lei Ching, can you have a try on that? What's meant by a very famous experiment? We call that fountain experiment. So you may see the water flows right with thermophiline. They would rises up the tube and go inside the brown bottom flask full of ammonia gas originally. Okay, so the wild water flowing up with in full speed. Okay, it seems like against gravity, they would rise up, and they would just spread through like a fountain, punching. Okay, why? Why would the water level rise up? Why? Anyone who can help, or maybe you may find the mic is not working, you may use the chat box.
因為嗰個 flask 入面嘅氣壓高過下面。
flask 嘅氣壓入邊高過下邊，入邊氣壓高啲，下邊就低啲。咁通常氣壓高低嘅話，由邊度走去邊度㗎？咁我哋唔使讀啦。黃奕朗係咪冇讀 geography 啊你？咁
冇讀啊。
係啊，咁我唔使咁凍啦而家。點解而家咁鬼凍啫？就係佢入邊高氣壓咁吹出嚟㗎嘛，係嘛？有高壓就咁吹落嚟，跟住我哋要凍啫嘛，大佬呢度上面北風吹落嚟啫嘛，咪高氣壓走去低氣壓嚇。咁咧入邊咧反而調翻轉啦。Okay, the flask inside they are of low pressure, lower pressure than before. Why? 見面又冇留意到我頭先佢做咗啲咩啊？佢滴一滴水落去個 flask 入邊，咁滴咗落去個 flask 入邊，咁個 flask 入邊咩嚟㗎？唔係空氣嚟嘅喎 ，is ammonia gas. So ammonia gas will dissolve. They try their best to dissolve into water. Okay, once they dissolve water, it reduces the pressure inside. Okay, because once it dissolves water, the volume original occupied will not be there, right? So but the flask will have a confined volume, right? So what is the hidden message? What's the hidden message? Less gas. Okay, less gas can be found inside the confined area. So the pressure, the particle that hit the surface will be less. Okay, so we'll call that the pressure will become lower. While the water over there, they will have a pressure higher than the one with a pressure lower. So they will have a driving force of pulling the water up. But while at the same time, the more water comes inside, the ammonia will start to dissolve more inside water to generate this environment much lower pressure. While this cycle continues. So you may see that the water level rises up will not go slowly. Instead, it goes quickly, and that driving force seems like making a fountain. Can you get the point？ 佢自己慢慢行上去咧，咁就唔會做到 fountain 嘅。咁點解會做到 fountain 咧？就唯一一個可以解釋就係咩啊？就係啲水咧喺上，好似下邊上好大力咁噴上去啦，係咪？明唔明？喺下邊，好似揸住飲管，你喺個水底度嚇，揸住飲管就等噴啲水上嚟咁樣，明啊？嗬？咁即係話咧，如果要令到啲水向上嗰陣時，其實我就要下邊一定要個壓力高過上邊啦。嗱，咁我哋喺下邊，我有冇揾人吹佢？唔使吹佢㗎。咁如果嗰個現象都係有一個 fountain 嘅話，唯一可以解釋係咩啊？就係個樽入邊個氣壓係低過喺水嗰度啦。明唔明白？咁你漸會做到一個氣壓嘅差咯，係嘛？唔一定係你要做到下邊嘅氣壓高過上面，有兩種做法㗎嘛，係咪？一就係你即係喺平時嘅常壓再加多啲，一係就本身嘅常壓度降低啲，咁你都可以做到一個氣壓差嘅，明唔明白？咁所以咧，原來咧，如果將入邊嘅氣體變成氧氣啊、二氧化碳啊、二氧化硫啊，你明明話用喺水嗰啲氣體度咧，你做唔到 fountain 嘅。點解啊？因為氧氣、二氧化碳、二氧化硫 SO2 呢啲氣體咧 ，the solubility is not so high when you compare with ammonia. Do you understand? So that's why we have got that very, very famous fountain experiment here. 一係 especially for ammonia because ammonia is highly water soluble. Do you understand? 明唔明？有咩問？有冇嘢唔清晰？呢度發生咩事？咁點解嗰個 thymethylene 要變成藍色嘅？ It tells you the solution is alkaline. Okay? Why is it alkaline? Ammonia gas dissolved in water, okay, and ionized to form what? Ammonium ion and hydroxide ion. While this, the slight excess of ammonia hydroxide ion, they will show the alkaline property. Okay, so we will make the thymethylene blue. Do you understand? 明啦嗬？明唔明？黃友樂明唔明？
還好。
明啊 ，OK 啊嘛？即係原來呢個係特別係 ammonia 先會咁啫，其他氣體咧做唔到呢個效果啊，因為其他氣體冇咁用嘅。呢個叫 ammonia fountain 嗱，咁你可以自己留意下啦。ammonia fountain 好特別嘅一個實驗嚟嘅。OK， 咁出年嗰啲 info day 嗰啲諗到做咩啦？ Now, so it is just a very special start for ammonia gas. So indeed, alkaline is also commonly found in our daily life. Okay, some of them they are quite natural, exist naturally. For example, slick lime. 熟石灰 do you still remember that one? It is in terms of slick lime I spray into the soil to reduce acidity soil, right? So, but most of the household chemicals found inside, it is found in kitchen or maybe in toilet. Okay, for example, drain cleanser, 通渠水 in which it will contain sodium hydroxide. And have you and you may have got a caustic soda. Okay, could you please mark it? Caustic soda, 哥士的，有冇聽過啊？ So how is it sold in the market? 哥士的 It's commonly sold like this. We've got a small white plastic bottle with the red cap, a very small cap, bottle. Times 3, it costs you $10. If you go to 五金鋪, and you may find that. So what is the use of caustic soda? It is also a type of drainage cleanser, especially while you talk about the drainage pipe, 污水渠, which is easily blocked by oil. We would use somewhat alkaline to do so. Why? Because we will say that alkaline is a degreasing agent. They can convert oil or grease into the soap, while the soap can be easily washed away by running water. So in the kitchen, while you have a blockage of the drainage pipe, please use alkaline for help. Okay, but remember, you handle that chemicals, handle that with care. Better wear the gloves because it's highly corrosive to you. For the milder chemicals, we will have a glass cleanser, which we may find ammonia, antacid tablet, in which you can have to take it and to reduce the stomach acid inside your stomach. Gastric juice. You know what's that? Stomach acid. Gastric juice inside. So you have got aluminium hydroxide and magnesium hydroxide, which can deal with the stomach acid. What is the chemical found inside stomach acid, which make it acidic? What is that acid? Hey, any biology students? Yep, good. Hydrochloric acid, HCl. All of you, please mark it down. HCl. So the presence of aluminium hydroxide, magnesium hydroxide, they can treat those stomach acid and reduce the acidity inside. It will let you feel less irritant to you, right? If you have got too much stomach acid, you will not feel well. 今日度知唔知道發生乜事？嗱 something what about the daily life examples? Questions? Now, if not, now if you refer to the, yes, that's right. Now this one, the characteristic of the dilute solution of alkalis. Before I show you another video, and please take a look on our reagent bottle. Now, the reagent bottle found in our chemistry lab is much different from this. Okay, we'll not use that type of combination. Of course, there will be no problem now because you may find this one, what material that makes it? It is plastic. It is glass. No problem. And in our past, we have once have a very old type reagent bottle with a glass stopper. Have you ever seen that? With that, like this, okay? A very traditional that combination. Now, in case I have the alkaline into this, sorry, not possible. Do you know why? Do you know why? Alkaline, what happened to the alkaline? If you have alkaline plus glass together, okay, they will have a reaction. What is the reaction?有冇人知？上網揾下好冇？點解alkaline 同 glass 兩個撞埋就會有反應，同埋有咩反應？咁同埋導致到個樽有咩問題？上網揾俾我，而家出去揾，我寫咗條 equation 啦。
佢個嗰個如果有啲 alkaline 嘅話，就會 react with 呢個 glass， 然之後就會有 dissolution。
係 dissolution 好啦，咁但係咧呢一種嘅 dissolution 有咩問題啊？如果我喺個樽嗰度，喺兩個，一個係樽有一個做glass， 即係而家有兩個一個樽蓋啦，個 stopper 啦，同埋個樽啦，都係玻璃，有啲鹼。咁長此以往點㗎？ 佢哋兩隻咧，佢兩個嘅玻璃片咧，最尾係會黐埋㗎。OK， 最尾會黐埋嘅。咁即係話咧，我哋一黐埋嘅咩問題啊？即係你個樽入邊嗰啲 chemical 咧，唔使旨意拎出嚟用啦。明唔明白 ？Attack glass 啱啱講緊呢度，係啦，啱啱講緊呢度。好，點 attack glass 啊？成條 equation，sodium silicate 加鹼變咗做咩啊？或者咁樣啦，講得簡單啲啦。或者 silicon dioxide 加鹼，識唔識啊？佢會有一個化反應㗎，叫 dissolution 啊。咁就會係點咧？黐埋啦。OK， 咁佢變咗呢個咩化學反應嘅？咁其實仲有嘅，應該係仲有 H2O 啊，你哋自己再 balance 翻條式啦。咁咧，你因為整咗個 silicate cell 咧，其實就會重新咧黐實咗呢兩個。咁所以咧，以前啲人咧揸住呢個樽咧，點樣解決咧？嗱，黐得實一實咧，就大件事就做唔到啦。但係如果佢哋仲你希望佢唔係黐得咁實咧，啲人會點咧？就將呢個 reagent bottle 落去台面度敲嘅，喺台面度敲個樽頸嗰度，睇下佢哋佢兩個會鬆翻嚟，可以開咗佢。但係而家我哋喺實驗室入邊，the reagent bottle to be used is much different from what we are having. First of all, we change it to screw cap, and with the glass bottle, right? Well, the screw cap, it's made up of plastic. 呢個係第一種嘛，我哋係膠樽蓋，藍色嘅、白色嘅啲膠樽蓋，個 container is made up of glass. But for storing alkaline, we will not use it. We will not use it. Instead, we have the whole bottle being plastic. You realize why? It's to avoid the sticking of the two chemical of the bottle and the cap, because alkaline would not attack plastic. Do you understand? 記住啦，你喺實驗室入邊，你留意下，逢親裝鹼嗰啲 chemical 咧，我哋唔係冇樽用㗎，我哋有樽用㗎，我哋係特登咧揾啲膠樽嘅，得唔得啊？玻璃樽嗰啲咧就唔係嚟嘅，玻璃樽嗰啲一定唔會裝鹼嘅，我哋用膠樽裝鹼，膠樽同膠樽蓋都係攞嚟裝鹼嘅，得唔得呢個配搭？嗱，因為咧我哋去防止呢種 attack glass 嘅現象走出嚟。好啦，you may see the lab commonly use alkaline, KOH, NaOH, lime water, and aqueous ammonia. They would feel slippery to you, which means that if you accidentally touch those chemical with bare hands, your fingertip will a little bit slippery. So why? Because they would convert the oil on your skin into the soap, and it will give you a bitter taste. Of course, you cannot taste it. Okay, so once you will feel somewhat slippery, what should you do? You better wash your hands thoroughly with running water. 記住咯喎，得唔得？如果你喺台面上面見有啲冇色嘅液體，你走嚟掂一掂佢，跟住咧就係滑潺潺嘅，就請你即刻洗乾淨啦，因為有機會係咩咧？有機會係我哋所講嘅即係嗰個嘅鹼嚟嘅，得唔得？好，而家咧我哋俾少少時間咧，你睇個 video 14.3 activity 14.3，講關於一個鹼嘅 化學反應，得唔得？嗱，呢個好 typical 化學反應，咁你自己留心喎。你應該有聲嘅，你冇聲你出聲啦，你哋。
In this experiment, you are going to investigate the effect of dilute solutions of alkalis on indicators, reaction of dilute solutions of alkalis with metal ions, and reaction of ammonium compound with calcium hydroxide.
First of all, I feel much discontented by this lab, right? Glass bottle with the glass stopper.
Pour 4 cubic centimeters of dilute sodium hydroxide solution into each of 3 test tubes.
Much better. It seems like plastic dropper, stopper, okay?
Add 2 drops of litmus solution, methyl orange, and phenolphthalein to each test tube separately. Record your observations. Litmus solution in dilute.
So first of all, the litmus solution originally is purple. Okay, once it meets alkaline, it turns to blue. Okay, second, methyl orange. It turns to yellow. But you see some of you see a little bit orange. While phenolphthalein are very obvious, right? The magenta color, pink to purple, right?
Sodium hydroxide solution appears as blue. Methyl orange in dilute sodium hydroxide solution appears as yellow. Phenolphthalein in dilute sodium hydroxide solution appears as red.
Okay.
Pour 4 cubic centimeters of dilute aqueous ammonia into each of 3 test tubes. Add 2 drops of litmus solution, methyl orange, and phenolphthalein to each test tube separately. Record your observations. Litmus solution in dilute aqueous ammonia appears as blue. Methyl orange in dilute aqueous ammonia appears as yellow. Phenolphthalein in dilute aqueous ammonia appears as red. Pour 2 cubic centimeters of aluminium ion solution, calcium ion solution, lead 2 ion solution, magnesium ion solution, iron 2 ion solution, iron 3 ion solution, copper 2 ion solution, and zinc ion solution into 8 test tubes separately. Add a few drops of dilute sodium hydroxide solution to the aluminium ion solution. Shake the mixture. Continue adding sodium hydroxide solution until no further observable changes. Repeat the above process by using the other 7 metal ion solutions. Record your observations. In the observations, white precipitate formed in aluminium ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution. White precipitate formed in calcium ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. White precipitate formed in lead-2 ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution. White precipitate formed in magnesium ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. Green precipitate formed in iron 2 ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. Reddish brown precipitate formed in iron 3 ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. Blue precipitate formed in copper 2 ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. White precipitate formed in zinc ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution. Replace dilute sodium hydroxide solution by dilute aqueous ammonia and repeat the experiment. Record your observations. In the observations, white precipitate formed in aluminium ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. No precipitate formed in calcium ion solution. White precipitate formed in lead-2 ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. White precipitate formed in magnesium ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. Green precipitate formed in iron 2 ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. Reddish brown precipitate formed in iron 3 ion solution. The precipitate does not dissolve in excess dilute aqueous ammonia. Blue precipitate formed in copper 2 ion solution. The precipitate dissolves in excess dilute aqueous ammonia. white precipitate formed in zinc ion solution. The precipitate dissolves in excess dilute aqueous ammonia. Put 1 spatula measure of solid ammonium chloride and 2 spatula measures of solid calcium hydroxide in a mortar. Mix the solids well by using a pestle. Put the mixture into a test tube. Warm the mixture gently. Hold a piece of moist red litmus paper in a stream of the gas given off. Record your observations. The moist red litmus paper becomes blue.
Oh, a very long YouTube video. I would like to share this to you as well. Let me see. I would like to give you that link also after today's lesson. Now, a very long YouTube video, and mainly we have covered 3 major type of the chemical reactions. Okay, one is the I would like to introduce to the last one, in which you may know it. I've just said it at the very beginning. A reaction of sodium hydroxide or calcium hydroxide in your video, or simply alkaline. Okay, having the metal hydroxide and especially potassium or sodium or calcium is also possible, and with ammonium compound. Okay, so the reaction will be either in solid or in aqueous for ammonium salts react with ammonia, so they would react to form ammonia gas and the salt and water. If you take a look on the ionic equation, it is ammonia, ammonium ion plus hydroxide ion heat to form ammonia gas and water. So that's why what I've just mentioned about the fountain experiment, okay, you may find it here, right? Okay, you may read those for details. Okay, this is the first equation I'd like to share with you. The second and third equation is the metal ion solution with alkaline. Okay, now for this part, I don't want to mention to you about electrical conductivity because it's self-explanatory. You know somewhat about mobile ions, right? How about this? The reaction with sodium hydroxide containing metal ions, we have got a list of different metal ion solution. And I add a few drops of alkaline and excess alkaline and try to see the difference in observation. Can you see the point? 少量嘅 NaOH 過量嘅 NaOH 睇一睇佢哋之間嘅化學反應。And indeed, you simply separate into 2 parts. One, they first of all lithium alkaline added to the solution. So you may find the calcium ion, magnesium, aluminium ion, lacto ion, zinc ion, they will all form white PBT. While that white PBT, they are on the form of hydroxide. So you may see that, Mr. Chin, there are so many metal hydroxides, they are not alkaline, right? They are just base. They cannot dissolve in water. Only 3 types of a hydroxide, metal hydroxide will dissolve in water. 知唔知道邊3種？係溶起水嘅。嗱，最溶起水嘅頭2隻 ，potassium hydroxide， 即係寫翻低啦。sodium hydroxide 都係溶起水嘅。嗱 ，calcium hydroxide 咧 So that's why once I add more hydroxide to it, there may be a concurrence of white PPT. Can you get the point? Now, how about iron 2? Iron 2, the color of the PPT, please change it. The name should be dirty green. Why is it dirty green? Because you may find that, right? It seems like what you see in some nasty place, right? Dirty green. While the iron 3 ion, the PPT form is iron 3 hydroxide, is reddish brown. The color seems like rust. While for blue, copper 2 hydroxide is pale blue. 天藍色. While you compare with a copper 2 ion solution, it's a little bit paler. Okay, this is point 1. And what's next is to talk about what will happen in excess alkaline. So you may find that some PPT will be dissolved and some of that will not. Okay, so you may find the 3 cases here. Aluminium, lead-2, and zinc, they precipitate will dissolve in a color solution. Why? Why is it like that? It's because of the formation of a complex. I try to put magnesium ion as example. I put it in the alkaline to form magnesium hydroxide, but that magnesium hydroxide will not form any complex. But for lead-2, zinc, and aluminium, they would, 3 of them, they will form a complex with the hydroxyl, tetrahydroxyl. Tetrahydroxyl means 4. Hydroxyl means hydroxide, ion surrounding them, with the common formula like this. It is made up of dative covalent bond. It is a complex. So I give you this one as example. You get what I mean. For lead, 2 ions react if in excess hydroxide, they will form a complex which is soluble in water. We call that tetrahydroxyl plumbate 2 ion, or we use the word plumbate ion. It carries the same meaning, right? It would like this. Similarly, for for aluminium hydroxide and zinc hydroxide, they will form it as aluminium. All of you, please mark it down. 4 with a minus here, and zinc hydroxide, and then 2 minus here with the name aluminate and zincate, respectively. Go home and please find out the equation. And I give you one more challenging question. What will happen if I have got silver ion react with NaOH? Give me 2 observations. One is dropwise of alkaline. What will happen? The other one is in excess. What will happen? Give me observation and give me equation if there is anything to explain the observation. Is that clear? Now, for the equation with aqueous ammonia solution with metal ions, I would prefer you take some time to read it by your own first. And then we will try to see you in the next lesson and we'll have a coverage. And before we leave, I would like to remind you that because of the current pandemic situation, we would not have any more face-to-face lesson shortly, okay, in the coming few weeks. We can do nothing, but try to have a Zoom supplementary lesson starting from next week. Is it possible to have it next Monday as usual? Anyone who cannot make it, now please PM me. Is that clear? Okay, now please type your level of understanding for today's lesson, okay, before you leave. Okay. For those who have typed your number, and you may now leave, and let's have a break. Thank you. Bye bye.借返啲分啊！鄭學明、譚君柔、黃成軒。